Okay, let's quickly look at naming of acids. Now I get two types of acids. The one is my binary acids. Binary acids is when you have an hydrogen that is forming a bond with any other element. So as soon as there's a hydrogen in front, I have an acid. So this is a binary acid. When I name this binary acid, I will not use the word hydrogen anywhere in the name. Instead, I would use the word hydro. So as soon as I see that, the first word would be hydro. But this is only if it's hydrogen combined onto another element. So the next one is the element that it's combined onto, in this case is chlorine. So chlorine also undergoes a name change. So the second part doesn't become hydrochlorine, it becomes hydrochloric. So I get the chlorine becomes chloric, and I add the word acid. So the first rule is you will use, if it's binary, you will use hydro for the hydrogen. The second element, second rule, second element will change and get a new suffix. So chlorine becomes chloric, and you will add the word acid. So this is hydrochloric acid. If I look at the next example, this is also a binary molecule. Why? It's because it's a bond between hydrogen and fluorine. So again, my first word will be hydro, the first part of the name. Then the second part, the fluorine, will become fluoric. So it will be hydrofluor. Instead of INE, it becomes hydrofluoric, and I add the word acid. So that is my binary molecules. Then the second type of acid that I get is called my oxyacids. Now an oxyacid is any hydrogen that's combined onto a compound oxyion. Oxyions are NO3, NO2, SO4, and we will look at some at these examples. So this NO3 is nitrate. Now you need to learn this. Remember, you got this in term 2, and when we did ionic bonding, and you have to know them. So NO3 is nitrate. Whenever the oxyanion is an 8, the name will change of nitrate will become nitric. And I do not use the word hydro, so in this case I only focus on my ion. My ion's name is nitrate, so it will be nitric. In other words, nitrate becomes nitric acid. That's it. If I have HNO2, NO2 is nitrite. When the suffix is an ITE, then I change the nitrate, the name nitrate, and I use a new suffix. Instead of I replace it with os. So this will be nitrous acid. Right, so when it is oxyacids, the naming is very easy. You must know your oxyions. If it's an 8, it becomes an X. So nitrate becomes nitric acid. Nitrite becomes nitrous acid. So the rule will be the same, for example, for this one. SO4 is sulfate. So this will become sulfuric acid, because the sulfate becomes sulfuric. I know that it loses the ATE, so it gets an UR for sulfur, sulfuric acid. And this becomes sulfurous acid. We can't call it sulfious. It won't work. So because of the fact that this is also a vowel, the A and the I, that's why I lose it, and I will use sulfurous acid, sulfuric acid. So I focus on the sulfur in this ion. With the nitrates, it is much simpler. So if you have, for example, HClO3, and this is chlorate, ClO3 is chlorate, and because that is an 8, this will become chloric. Chlorate becomes chloric the 8 becomes an ic, chloric acid. If it's HClO2, so this is chlorate, this is chlorite. Because this is an ite, this will be chlorous acid. Right, so that is the naming of acids.